Alright, today we're going to talk about relations and functions, okay? By the end of the day, you should know what a relation is, what the domain is, what the range is, and you also need to be able to draw a set and an ordered pair. Okay, so a relation is a set of what?
Ordered pairs.
Ordered pairs. Okay, the number 2, 4 is an ordered pair. 2 stands for, is the what value? The x value. And 4 is the what value?
Y.
The y value. Okay, so in this, x equals 2, y equals 4. But this is an ordered pair. So they're saying a relation is a set of ordered pairs. Okay, this little bracket means you're drawing a set. Okay, everything inside this will be the set. Okay, so if I do 2, 4, -1, 3, 8, 1. Okay, I have a set of ordered pairs, which makes this whole thing a what?
Set.
No, what's it say right there?
A relation.
A relation. Okay, it is a set, but because it has ordered pairs in it, it's now a relation. Okay. Now, they're going to want you today to find the domain and the range of this relation. Okay? It says here, the set of the first coordinates is the domain. So the first coordinates would be 2, -1, and 8. So all the x values are the domain values. Their domain. Okay? And all the y values are the range. Okay, so your x's are your domain, your y's are your...
Range.
I can't hear you?
Range.
Okay. Alright, so let's look at an example. Let me give you a quick example. Let's say we've got this relation. Now, why is this a relation? It's a set of ordered pairs. Very good, Zach. Okay? Now, in this set of ordered pairs, I want you to tell me the domain, yeah, and the range. Okay? In this set of ordered pairs, I want you to tell me what the domain and the range are. Now, the domain is all the x values. So this 2, this 1, and this -1 are all the domain. So in our domain set, we're going to write 2, 1, -1. Okay? Now, in the range, it's all the y values. So we've got 4, 3, and -6. So in the range, our range is going to be 4, 3, and -6. Okay, so the domain was all the x values, the first values, and the range was all the y values, the second values. Please copy this in your notes. Now, we're going to talk about here what a function is. Earlier we talked about a relation. Now we want to talk about a function. It says up there, a function is a relation in which each element in the domain is paired with exactly one element in the range. This in college you'll learn is called 1-to-1. Okay? Another way to write that is 1 and then a :1. Okay? 1-to-1. Now, what you say, what does that mean, 1-to-1? Well, if you've got one man, he's supposed to only have one woman, right? So one man to one woman. Okay? So now in a function, let's say we have x plus 2, and I tell you x equals 3. Okay? And you plug 3 in here, what do you get?
3 plus 2.
Which is 5. So x equals 3 and y equals 5. So for 1, 3, you get 1, 5, right? 1-to-1. Alright? Whenever you do have it as 1 to 1, then it is going to be a function. When it's not 1 to 1, when it's 1 to 2 or 1 to 3, then it won't be a function. Okay, and I'm going to explain that a little better for you in a second. Now what they use is called the vertical line test on a graph. So let's say that's my graph. Okay, if my graph looks like this, you know a vertical line goes up and down, right?
Yes.
So let's say we have this ruler which goes up and down. Now in the high school they'll call this the pencil test. But if I drag this across my paper, is there any point where my ruler touches the graph more than once? Okay? Now, no there's not. Now when I talk about the graph, I'm talking about this part here. Okay? This is the graph. Now these are the coordinate planes, they don't count. So Rico, is there anywhere that my ruler is going to touch the graph 2 times at the same time? No, just once. So this is a function. Okay? Now, if you have a graph like this, okay?
Is that a really?
Watch it. Let's say you have a graph like this. As I take this across, does it connect more than once here?
No.
Yeah, it does.
Yes,
It
it
connects
does.
3 times. It connected 1, 2, 3. 3 different times, right? So it's not a function. Does this connect 3 times more than once?
Uh-huh.
No, so it is a function. Does this connect more than once?
No.
Yes, so it's not a function. This is the vertical line test. This is my vertical line. Do you understand that? Now in your paper you can just take your pencil and roll it across and say, oh, it crosses more than once, so it's not a function. Do you know what I mean by crosses? Let's say this is my vertical line right here. Okay? It crosses 1, 2, 3 times. So it's not a function. You see that? That green line where my ruler, it crosses the graph 3 times, so it's not a function. But let's say I put my ruler right here. How many times does it cross the graph? Once. So it is a function.
Oh, I get you.
Okay? Now let's say you have this graph. Is this a function?
No.
No, because right here it's going to cross twice. Right here it's going to cross twice, making it not a function. Okay?
So that one function right there?
Neither of these are not, these are both not functions. This is a function. It can only cross once for it to be a, think of it, only one woman for one man. This man has 3 women, so he's not a function. You understand?
Yes.
Because you can think of it this, hey, you can think of this as times in his life. When he was 6 years old, when he was 20, he had 3 girlfriends, so he's not a function. Whereas over here, no matter where you look in their life, it's only one girl. Right? You understand? I don't know how to explain it any better than that. Okay?
Love it here.
Oh, how can you see it right there?
Okay.
Yeah, I have to use what you're looking at.
Yeah.
Alright, so now let's look at this graph, and we're going to create a relation out of it. Now, what point is this right here? 1, 2, 1, 2, 3. It's the point 2, 3. Okay? What is this point? 3, 2. So you see what we're creating? What are we creating? A set, and it has more than one ordered pair, which makes it a relation. This point right here is going to be 1, 2, 3, 4, 2. Okay? Now, our domain is what?
2,
2, 3,
4.
and 4. Okay? Our range is what?
3,
3, 2, 2. Now, another way you can tell whether it's a function. Okay, your question is this a function? Okay, that's the question. So, if the same number occurs twice in the domain, it's not a function. Okay? If the same number does not occur twice in the domain, it is a function.
So it is.
Now the range doesn't matter. It can occur as many times as it wants to in the range. Okay? But does any number occur more than once in the domain?
No.
No. So this is a function. This is a function. Now we're going to work a bunch of these. But are you seeing what I'm talking about so far? So let's look at this one. They give you, what do they give you? They give you the relation, don't they? So you need to know the domain equals 2, 3, 2. Right? 2, 3, 2. Now the range is going to equal 7, 8, 1. Now the range doesn't matter towards whether it is a function. See, it tells you, tell the domain, tell the range. We did those. Now it wants to know, is it a function? Well, 2 and 2 both occur in the domain, so this is not a function. So I'm going to put one up there for you to try. So please try that one. Alright, now we have the relation up there and wants us to tell the domain. What's the domain, LA? 11, negative 5, and 13. Good. What's the range, Natalia?
-4, -3, -3.
Good. Now, is this a function? Yes. Because no number occurs twice in the domain. The range doesn't matter. So yes, it is a function. Okay? Now let's try another one. Well, now look at this one. This one says express the relation shown in each table or graph as a set of ordered pairs. So you got to make this an ordered pair. There's your x. Oops. This right here is your x, and here's your y, so your ordered pair is 0, 3. Your ordered pair here is negative 1, 4. And your ordered pair here is negative 3, 9. Okay? So you made ordered pairs. Now it says state the domain and range. See right here? State the domain and range. So the domain is going to equal 0, negative 1, negative 3. And the range is going to equal 3, 4, and 9. Okay? So now the last thing says, then determine whether the relation is a function. Okay? Do any of these occur twice? No. So is this a function?
Yes.
Yes, this is a function. On this one, you got to tell the ordered pairs as well. Okay? This point right here is what?
-2, -3.
Negative 2, 3. This point right here is what? Negative 1, 3. This point here?
-1, -1.
Negative 1, negative 1. This point here?
-1.
Oh, it's positive 1.
+1, 3.
Positive 2. Positive 1, positive 2. And what's this one?
3.
Negative
Can you not
2.
count?
Negative
1, 2.
-1.
2, negative 1. Okay? So now you got to close your set, because that set makes it a relation, because it's a set of ordered pairs. And your domain is going to equal 2, negative 2, negative 1, negative 1, and 1. Your range is going to equal negative 1, 3, 3, negative 1, and 2. Now the question is this a function?
No.
Well, you've got two of them that occur twice, so no, this is not a function. Alright, so right here we've got to substitute 3.2 in everywhere there's an n. Okay, so we've got f of 3.2, and then in the equation, instead of n, what do I put? 3.2 squared minus 2. Now 3.2 squared is 10 point something, what?
I don't know.
Use your calculator. Alright, so 3.2 squared is 10.24 minus 2. So what does 10.24 minus 2 equal?
8.24.
8.24. And that's your answer. Okay, so let's look at another one. On this one, we got to substitute -4 for every place that there's an n. So I've got f of -4 equals, now instead of n, what do I write? -4 plus 5. So now -4 plus 5 is? 1. And that's your answer, 1. But now you got to write all this just like I did. If you just write 1, it's not right. Okay? So now let's try this one. F of 0.5. So everywhere there's an n, I got to put 0.5. Okay? So I've got f of 0.5 equals 0.5 times 0.5 plus 1. Now instead of 0.5 times 0.5, let's change it to 1/2 times 1/2 plus 1. Now what's 1/2 times 1/2? 1 times 1 is 1. 2 times 2 is 4. So it's 1/4 plus 1. And 1/4 plus 1 is just 1 and 1/4, which equals 1.25. Very good.